Question 14, Electrical Engineering, GATE 2017, Set 1. For the circuit shown in the figure below, assume that the diodes D1, D2 and D3 are ideal. The DC components of voltages V1 and V2 are. 4 options are given to us, and for a detailed lecture on the basic concepts of electrical circuits, please refer the NPTEL video Basic Electrical Circuits by Professor S.C. Dattaroy, Department of Electrical Engineering, IIT Delhi. In order to solve this problem, we need to know the method to find out the average value of a given AC waveform. Consider this waveform. It has a peak voltage of, let us say, Vm. The instantaneous voltage is given by Vm sin omega t, where omega is the angular frequency of this signal. The average value of this would be 1 divided by the time period, integrating from the limit 0 to time period, V of t d omega t. In this case, the time period of a sine wave is 2 pi, where from 0 to pi it is in the positive half cycle, and from pi to 2 pi it is in the negative half cycle. Therefore, this integral splits into 2. So we have to integrate from 0 to pi Vm sin omega t plus integral pi to 2 pi Vm sin omega t, and this is integrated with respect to omega t. Let's make use of this concept to solve this problem. Here it's given that the diodes D1, D2, D3 are ideal diodes. Therefore, when it is forward biased, it is said to be an on condition, or we can replace it by a short circuit. Under reverse bias, the diodes will not be conducting, and hence it is said to be an off condition, or it can be considered as an open circuit. During the positive half cycle, the current flows through this path, so the diode D1 will be on, D2 will be off, and when it comes back, D3 will be off. Therefore, the conduction is through D1 alone. The current will go through this R via this D1 and towards the next resistor R, and it will circulate back into the source. Therefore, this is a series circuit consisting of 2 resistors of value R. Therefore, during the positive half cycle, the circuit can be replaced like this. Since their magnitudes are same, the voltage will be shared equally by both of the resistors. So, V1 of t is same as V2 of t, which is same as V of t by 2. This is during the positive half cycle. Therefore, V1 of t is equal to V2 of t, that is equal to pi by 2 sin omega t. It is given that it is pi sin 100 pi t. For time being, let us have this to be as omega t. Later on, if required, we will substitute the value of angular frequency as 100 pi. Now, during the negative half cycle, the current passes through this loop, and hence D3 will be forward bias, so it can be considered as a short circuit, and when it circulates back to the source, it will go through D2. Because only D2 is forward biased, D1 is in off condition, or it can be considered as an open circuit. Therefore, the conduction is through the source via the shorted path of D3, then it goes via D2, then it goes to the resistor R and then circulates back into the source. So, there won't be any current passing through this resistor R. The current will directly pass into the short circuit back to this resistor. During the negative half cycle, the current flows through the shorted path back to the resistor R. This second resistor is connected in parallel to this shorted path, therefore no current will flow through this R. Therefore, V1 of t will be V of t, which happens to be negative, which is equal to pi sin omega t, and V2 of t will be 0 volt. Now, let's find out the value of average voltage. During the positive half cycle, V1 of t as well as V2 of t will have a peak voltage of pi by 2, and during the negative half cycle the value of V1 will be pi sine omega t and V2 will be 0 volt. So the average value of voltage is from 0 till 2 pi, that is one time period. Let's calculate that. The value of average voltage of V1 will be 1 divided by 2 pi into the integral from 0 to pi by 2 sine omega t with respect to omega t plus integral pi to 2 pi sine omega t with respect to omega t. This will be 1 divided by 2 pi. When we integrate sine omega t, it will be minus cos omega t from the limit 0 to pi, and for the second term it will be minus cos omega t from the limit pi to 2 pi. So the V1 average will be pi by 2 pi into 1 minus 1 plus minus 1 minus of minus 1. So on cancelling the terms we will be getting 1 by 2 times half plus half minus 2. This is equal to minus 0.5 volt. Similarly, the average voltage of V2 is given by 1 by 2 pi into the integral 0 to pi by 2 sine omega t with respect to omega t plus from the limit pi to 2 pi it's 0. Similarly, this will come to 0.5 volt. The answer is option B, minus 0.5 volt and plus 0.5 volt. Thank you.